Viewers at home, you are welcome to my presentation on the Simplex method of solving linear programming. If you are just coming across this channel for the first time, please don't forget to like, share and subscribe. So, what do we mean by linear programming? Linear programming is a mathematical modeling approach used to allocate the limited resources among various competing products under multiple constraints. The word multiple constraints should be underlined, meaning that the limiting factors, the constraints benefit the organization will be more than one. So that is what we mean by multiple constraints. Application of linear programming requires, for linear programming to be used, the constraints facing this entity or facing the organization must be more than one. So that is why I say it's a mathematical modeling approach used to allocate the limited resources among the various competing product lines under multiple constraints. So in my first video, I've examined the formulation of linear programming and how to solve questions involving linear programming using simultaneous equation method. The second video also, I've examined how to solve linear programming using graphical method. In this video, I'll be focusing on the Simplex method of solving linear programming. Simplex method of solving linear programming. What do we mean by the Simplex method? Simplex method of solving linear programming. Simplex method is a step-by-step approach used to solve linear programming in which one graduates from one feasible solution to another better feasible solution until the optimal solution is reached. Simplex method is a step-by-step approach or step-by-step method used to solve linear programming in which one graduates from one feasible solution to another better feasible solution until optimal solution is reached. So, optimal solution is reached where all the variables in the objective function, where they are all zeros or negative. Where you have all the variables in the objective functions equal to 0 or negative values, it is then that the optimal solution is reached. So what are the key concepts or the key terms used in connection with the Simplex method? Definition of key terms. Key terms. Definition of key terms. Number one is slack variable. Slack variable. Slack variables represent the unused capacity in the constraint. Slack variables represent the unutilized resources in the constraint. The unused resources, unused capacity in the constraint as said to be the slack variable. Now, the second one is the pivot. A pivot column in the objective function, is the column with the largest value in the objective function. Pivot column is the column with the largest value in the objective function. What are the steps for solving linear programming using the Simplex method? Steps for solving linear programming using the Simplex method. The first steps now. Step number one, formulate the linear programming Formulate the linear programming objective function and the constraint. Formulate the linear programming objective functions and the constraint. Step 2 is to turn the inequality to equality. Turn the inequality to equality by adding slack variable to each constraint function. That is step number 2. You turn the inequality to equality by adding the slack variable to each constraint function. Step 3. Arrange the equation in matrix form. I want you to know that these steps will be better explained with work example. So if you are still confused or if you see these steps to be too ambiguous, just pay attention. You will understand it better by the time I take a work example. Step 4. Identify the pivot element and ring it. Identify the pivot element and ring it. Identify the pivot element and ring it. I want you to know that the pivot is obtained by dividing the solution quantity. That is the maximum available element for each of the constraints. That is what I mean by solution quantity. By the corresponding number in the column with the highest value in the objective function, in the maximization objective. Divide the solution quantity by the corresponding number in the column with the highest value in the objective function, in the maximization objective. That is step 4. Step 5. Divide all the elements in the pivot row by the value of the pivot element. Step 5. Divide all the elements or all the variables in the pivot row by the value of the pivot element. So this will now make the value of the pivot element to be 1. It will make the value of the pivot element to be 1. Step 6. Obtain the new value for each row. Obtain the new value for each row. And this is done by subtracting the old value in the row minus value of the pivot minus the corresponding value in the pivot row. The old value in that pivot row minus the corresponding value in the pivot row. Bearing in mind that you want to turn all the numbers in the pivot column, you want to turn them to 0, except the pivot row where that one you have there will be retained. That is what you should take note of. The last step, which is step number 7. Repeat the above steps until the optimal solution is reached. Repeat the above steps until the optimal solution is reached. Remember, I've told you that optimal solution is reached where all the values in the row containing the objective function, where it is all 0 or negative. That is, all the value in the objective function will be negative or zeros. I want you to know that Simplex method can be used to solve problems on linear programming where the number of variables involved is more than 2. But graphical method can only be used where the variables involved does not exceed 2. Now I want to take a work example. Example: a company can produce 3 products, A, B, and C. The products yield a contribution of 8 sterling, 5 sterling, and 10 sterling respectively. The products use a machine which has 400 hours capacity in the next period. Each unit of the products uses 2, 3, and 1 hour respectively of the machine's capacity. There are only 150 units available in the period of a special component which is used singly in products A and C. 200 kgs only of special alloy is available in the period. Product A uses 2 kg per unit and product C uses 4 kg per unit. There is an agreement with a trade association to produce no more than 50 units of product B in the next period. The company wishes to find out the production plan which maximizes contribution. That is the question. Now, let's have the solution. Now, I have told you, in my previous video, I have explained how to formulate linear programming. Now, solution. The first step is the formulation. Step 1, we have the formulation of the linear programming. Formulation. Now, the first thing will be the objective function. Objective in this case will be to maximize. You want to maximize the contribution. Let's use contribution. Let's denote that by Z. And what are the products involved? And what are their contribution? The product is a contribution of 8 pounds sterling, 5 sterling, and 10 sterling respectively. Now, that means for A, 8 sterling, B, 5 sterling, C, 10 sterling. So, you have 8A plus 5B plus 10C. That is the objective function. Then the next thing is your constraint. We put subject to, for better understanding of formulation and how to solve linear programming using other methods I've considered. I will advise you go over my previous videos. The products use a machine which has 400 hours capacity. The machine capacity is 400, so this capacity is limited to 400 hours. The machine capacity is limited to 400 hours. That is a constraint to the entity. In the next period, each unit of the products uses 2, 3, and 1 hour respectively of the machine capacity. So the first constraint is the machine capacity. Machine capacity. the capacity for product A, we have 2 hours, 3 hours for B, and 1 hour for C. 2. So machine capacity, we have 2 hours for A plus 3 hours for B plus 1 hour for C. So you can just put C, you don't need to put 1 since it is 1 hour. 1C. So less than equals to the available machine capacity is 400 hours. So that is one of the constraints. Constraint number 1. There are only 150 units available in the period of a special component. The maximum availability of the special component is 150 units. So that is also a constraint by the organization, because they cannot get more than 150 units of that special component, which is used singularly in products A and C. So product A and C, the special component, the available is 150 units. So special component is also a constraint. Special components, which is available for A and C, and we have less than equals to 150 units. 150 units is available. Then 200 kgs only of special alloy is available in the period. Special alloy 200 kgs is only available. That is also a constraint. Product A uses 2 kg per unit, and product C uses 4 kg per unit. 2 for A, 4 for C of the 200. So which is special alloy. Special alloy. The constraint. Product A uses 2 kg and product C uses 4 kg. That is 4 of C. Less than equals to the available is 200. There is an agreement with a trade association to produce no more than 50 units of product B in the period. The maximum unit of B you can produce is 50. So that is a trade sales restriction now. Sales or production or trade restriction. Sales or trade restriction. The maximum unit of B is 50. So we have B not exceeding 50. That is for this. You are to, the company wishes to maximize the production plan, which maximizes contribution. Now, this is the formulation. To complete the formulation, the next thing is non-negativity. Non-negativity. None of the variables involved must be positive. A must be negative rather. None must be negative. A, B, and C. For them not to be negative, they must exceed 0 or exactly equal to 0. A must be greater than or equal to 0. B must be greater than or equal to 0. While C also must be greater than or equal to 0. That is the formulation of the linear programming. So that is step 1. Step 2 now, having completed step 1, step 2 now is to introduce slack variable. We introduce slack to each of the constraints. The first constraint is the machine capacity. Let's introduce slack. So the equation is 2A plus 3B plus C greater than or equal to 400. We change it to equality. So we have 2A plus 3B plus C, then plus slack 1. Let me call that slack 1, where S1 is slack, equals to 400. You equate it to 400. Then the second one, A plus C, A plus C, then plus slack 2. That one is equals to 150. Then the third one, we have 2A plus 4C plus slack 3 now equals to 200. While the fourth one, we have B, that is B, plus slack 4, that one is equal to 50. That is step 3. You arrange this equation in matrix form. Step 3. Let's arrange the equation in matrix form. We have solution variable, and we have variables A, B, and C. A, B, C. Then you have 4 slack. Slack 1, slack 2, slack 3, slack 4. Then solution quantity. Solution quantity. Now, the first equation, we have S1 there, slack 1. So we put slack 1 under the solution variable. The coefficient of A is 2. That of B is 3. Coefficient of C is 1. The coefficient of slack 1 is 1, but no slack 2 in this first equation. So you put 0. No slack 3, you put 0. No slack 4, you put 0. And you have it equal to 400. You put the 400 under the solution quantity. Then, the second equation contains slack 2. So you put S2. The coefficient, we have A there. Coefficient of A is 1. No B. So you put 0. Coefficient of C is 1. No slack 1. So that means you have a 0. We have slack 2. So you put 1. No slack 3. You put 0. No slack 4. You put 0. And we have it equal to 150. You have it equal to 150. The third equation contains slack 3. So you put S3. So in the equation that contains slack 3, we have coefficient of A to be 2. No B there. So you put 0. Coefficient of C is 4. No slack 1. So you put 0. No slack 2. You put 0. We have slack 3. Coefficient of slack 3 there is 1. No slack 4. So you put 0. And we have it equal to 200. Step S. The fourth equation contains slack 4. So we have S4. In the S4, no A. So coefficient of A will be 0. We have B. Coefficient of B here is 1. That of, there is no C. So you put 0. Then there is no slack 1. So you put 0. No slack 2. You put 0. No slack 3. You put 0. Slack 4 is 1. So we have it equals to 50. Now, our objective function. We have Z equal to 8A plus 5B plus 10C. Coefficient of A is 8, B 5, C 10. So we have Z. Coefficient of A is 8. Coefficient of B is 5. That of C, 10. No slack there. So you put 0. No slack 1, no slack 2, no slack 3. And we don't have the value it's equal to. So this equation have been arranged in matrix form. Then step 4. You want to identify the pivot. I've told you that to identify the pivot, look at the equation. Look at the objective function. What is the highest value in the objective function? The highest value in the objective function is 10. So that means this column that contains 10 will be the pivot column. But you don't know what the value of the pivot will be. So you take the value in the solution quantity here and divide it by the value in that column. So we have 400 divided by 1, 150 divided by 1, 200 divided by 4, 50 divided by 0. So now let's do that. 400 divided by 1. We have step 4. Step 4, 400 divided by 1 will still be 400. The second one, we have 150. 150 divided by 1, that will be 150. The third one, we have 200 divided by 4, and that will be 50, and also 50 divided by 0. 200 divided by 4, that gives us 50. 50 divided by 0, that will be 0. Anytime you have a 0, that one will be ignored. The one that produces the least value is this. Therefore, the pivot is 4. The 4 we use to divide this to give us the least value. That 4 is the pivot. So now, let's ring the pivot now. You know, we have solution, variable, where we have A, B, C, S1, S2, S3, S4, and solution quantity. Solution quantity. So we have S1. So I'm filling in from the step 3 here. I'm filling in the value there. 2311000 S1 2311000 400. S2 from that table we have 101 101. Then we have 01 00, and that is 150. Then S3 we have 204 204 001 0010, and that is equal to 200. Then we also have S4, which is 0 1 0 0 0 0 1. We have that equals 50. And the value in our objective function, we have Z, which is 8510 8510 0 0 0 0 0. Then our pivot, as identified above, our pivot is 4. So we ring it. So that is our pivot. Having identified the pivot, then the next thing is to divide everything in this pivot row by the value of the pivot, which is 4. So that means the row S3 now. So this S3 will disappear. It will now be replaced by the C at the top. Any letter in that pivot column will replace the slack in the pivot row. So the new row C now, it will become row C, no longer row S3. Row C now, row C. You know, the old value you have 2 0 4 0 0 1 0 200. You divide each by the pivot, which is 4, divided by 4. So if you divide it by 4, now our pivot is 4. So you'll be left with 0.5. That means our row C becomes 0.5. 2 divided by 4 is 0.5. 0 divided by 4 is 0. 4 divided by 4, 1. Is 0, is 0, 0.25, 0 and 50. So now let's have second simplex tableau. So you have solution variable ABC S1 to S4 and SQ. Solution variable A, B, C, S1, S2, S3, S4 and solution quantity. So our S1, we have 2, 3, 1, 2, 3, 1, 1, 0, 0, 0, 400. 1, 0, 0, 0, 400. So row S2, we have 1, 0, 1, S2, 1, 0, 1, 0, 1, 0, 0, 150. 0, 1, 0, 0, 150. You know, I've told you that this will no longer be S3. It will be the C. So that means this S3 will disappear while this change to C. And we now have the value of the pivot, the new value we have in the pivot row. No longer this. The value obtained after dividing each number or each element in the pivot row by 4, which is the value of the pivot. So our C now, our row C now, what you have, which is 0.5, 0, 1, 0, 0, 0.25, 0 and 50. Then we also have row S4, which is 0, 1, 0, S4, 0, 1, 0, 0, 0, 0, 1 and 50. 0, 0, 0, 1, 50. We now have the objective function, which is 8, 5, 10, 8, 5, 10, 0, 0, 0, 0 and 0. 0, 0, 0, 0, 0. So that is the second table. Then to obtain the third table, remember this is the pivot. This is the value of the pivot. This one was obtained by dividing the 4, which is the value of the pivot, this 4 by 4. So that means our pivot is 1. So your target now is to turn each element in that pivot column to be 0. You turn them to 0. You want this to be 0, this one to be 0, pivot will be 1. This is already 0, this will also be 0. That is your next target, to form a new table. So now let's have third simplex tableau. Third simplex tableau. So we have solution variable A, B, C, S1, S2, S3, S4 and solution quantity. Now, the first row is row S1. Our old row S1. Our old row S1, we have 2, 3, 1, 2, 3, 1. Our pivot, slack variables, 1, 0, 0, 0, 400. 1, 0, 0, 0, 400. Then you now take the pivot row, which is row C. Our pivot row is 0.5, 0 and 1, 0.5, 0 and 1, 0, 0, 0.25, 0 and 50, which is still the same number we have obtained here. 0, 0, 0.25, 0 and 50. 0, 0, 0.25, 0, then 50. You know, this is the value of the pivot. You want everything in that column to be 0. So that means everything here, you want it to be 0. Since you have 1 here, by subtraction, if you subtract, 1 minus 1 is 0. That means you can subtract it to turn that to 0. So 2 minus 0.5, that will be 1.5. 3 minus 0 is 3. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 0.25, that is minus 0.25. 0 minus 0 is 0. 400 minus 50, then that gives us 350. So that is the new row S1. So we substitute that. 1.5, 3, 0, 1, 0, minus 0.25 is 0 and 350. Then row S2. Let's have old row S2. The old row S2, we have 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 150. 0, 1, 0, 0, 150. Then our pivot row, which is row C. Row C, that is 0.5, 0, 1, 0, 0, 0.25, 0 and 50. Now let's subtract. New row S2 now. 1 minus 0.5, that will be 0.5. 0 minus 0 is 0. 1 minus 1 is 0. So this row becomes 0. So this column becomes 0. Then 1 minus 0 is 1. 0 minus 0.25, that is minus 0.25. Then this is 0, while this gives us 100. This is new row S2. We have 0.5, 0, 0, then 0, 1, minus 0.25, 0 and 100. Then the next thing after S2 is row C, which is the pivot row. So the value will still retain its identity, 0.501. Row C now, which is 0.501. Then we also have 0, 0. Then we also have 0.25. Then we have 0 and 50. After row C, we have row S4. Remember, your target is to turn everything within this column to 0. And since this is 0 already, so you don't need to subtract. Just write everything you have there already. 0, 1, 0, 0, 0, 0, 1, and 50. We have row S4. 0, 1, 0, 0, 0, 0, 1, then 50. Then the next thing is the objective function row. We want everything here to be 0. We want this to be 0. This row Z, that is our objective function row. So we have old row Z. The value of that row we have 8, 5, 10, 8, 5, 10, 0, 0, 0, 0, 0. We have 8, 5, 10, 0, 0, 0, 0, and 0. Then row C, that is our pivot row, which is 0.5, 0, 1, 0, 0, 0.25, 0, and 50. Our target is to turn everything within the pivot column to 0. So you want this column to be 0. If you have 10 minus 1, it will give us 9, not equal to 0. That means for this to be 0, this has to be 10. So that you can now have 10 minus 10 equal to 0. Therefore, you will need to multiply 1 by 10 to make this 10. So 1 times 10, that will be 10. 10 minus 10, that will be 0. So that means each element in this row, that is our pivot row, you have to be multiplied by 10 before you subtract. So 0.5 times 10, that will give us, it will give us 5. 8 minus 5, we have 3. That is new Z row. 10 times 0, it will be 0. 5 minus 0, it will be 5. 10 times 0 is 0. 0 minus 0 is 0. This will be 0. 0.25 times 10. That gives us 2.5. 0 minus 2.5, that gives us minus 2.5. Then 10 times 0 is 0. 0 minus 0 is 0. 10 times 50 will be 500. 500, 0 minus 500, that gives us minus 500. So this is our new row Z. No, this was obtained by multiplying this one by 10 before you subtract. So our new Z row will be 3, 5, 0, 0, 0, minus 2.5 is 0, and minus 500. I've told you that optimal solution is achieved when all the values within the objective function row when it turns to 0. And we still have 3 when it turns to 0 or negative. We still have 3 and 5, which are not 0 or negative value at the objective function row. Therefore, you have to identify the new pivot again. So I've told you that to identify the new pivot, you use the column with the highest value in the objective function column. So this is the highest value. 5 is the highest value in the objective function. So we are going to use this column. We divide element here by the element here. Therefore, we have 350 divided by 3, 350 divided by 3, 100 divided by 0, 50 divided by 0, 50 divided by 1. So this one gives us 350 divided by 3. That gives us 166.7. 100 divided by 0, that gives us is 0. 50 divided by 0 is 0. 50 divided by 1, it gives us 50. So I've told you that whichever one, anyone that gives us 0 should be ignored. So these two should be ignored. So the list is this. Therefore, this one should be our new pivot. So since it is turning to our new pivot, that means this is our new pivot now. So we also divide everything here by 1, but if you divide them by 1, it will still remain the same. I've told you that the letter you have in this column will replace whatever the slack variable you have here. That means the S4 will disappear. So now our solution variable, we have A, B, C, S1, S2, S3, S4, and solution quantity. So this will be the fourth simplex tableau. So we have S1, S2, we have S1, S2, then we have C. Then I've told you that in place of S4, since S4 is our new pivot row, we are going to replace this S4 by B at the same column with our pivot number or pivot element. So we have B in place of S4, while S4 will disappear. So we have B. So now what will now be the pivot column? Since this is 1, so just that means this will remain unchanged. 0, 1, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, then we have 50. Now, our target is to turn everything in this column to 0, except this one. So this one, we want it to be 0. Our old row S1 now, let's have old row S1, we have 1.5, 3, 0, 1.5, 3, and 0. Then we have 1, 0, minus 0.250, and 350. 1, 0, minus 0.25 is 0, and 350. You now take the row B now, which is the pivot row, row B. Our new pivot row, our pivot row, which is row B. We have 0, 1, 0, 0, 0, 0, 1, and 50. So we have 0, 1, 0, 0, 0, 0, 1, and 50. Our target is to turn everything within this column to 0. So for this to be 0, if you have 3 minus 1, it will be 2, not equal to 0. That means this has to be 3. So you have to multiply this row by 3. So 3 times 1 will be 3. 3 minus 3 is 0. Then 0 times 3 will be 0. 1.5 minus 0, that will still be 1.5. 0 times 0 is 0. 0 minus 0 is 0. 0 times 0 is 0. 1 minus 0, it will be 0. This will be 0. This one remains minus 0.25. 3 times 1 will be 3. 0 minus 3 will be minus 3. 3 times 50, that will be 150. 350 minus 150, that will be 200. So this is new row S1. So let's put that this in row S1. 1.5, 0, 0, 0, 0. Row S1, we have 1.5, 0, 0, 0, 0, minus 0.25, minus 3, and 200. Minus 0.25, minus 3, 200. Then row S2 now. Old row S2. Our row S2 we have 0.5, 0, 0, 0, 0.5, 0, 0, 0. Okay, this column is already 0 in case of S2. No need of subtraction. So just put the number there. So we have 0.50001 minus 0.250 100. Remember, our target is to turn everything within this column to 0. Since this is 0, so just put that value directly. So S2 now will be 0.5000 1 minus 0.250 1 minus 0.25 and 0. Then we have 100. Then row C, this is already 0 as well, so you don't need to change anything. So replace it. 0.501 0.501 00 0.250 00 0.250. Then we have 50. Then our Z row now. Our Z row, which is our objective function row. Now we have old Z row or old row Z. We have 350 350. Then we have 00 minus 2.50 00 minus 2.50 and minus 500. That is our Z row. Then our pivot row, which is row B, is 01000150. Our row B, which is our pivot row, we have is 01 0 0 0 0 1 and 50. That's our pivot row. Our target is to turn everything here to 0. You want this to be 0, and for that to be 0, you have to, if you have 5 minus 1, it will be 4, not equal to 0. You have to multiply this by 5 times 5. So 5 times 1, it will be 5. 5 minus 5 is 0. 0 times 5 is 0. 3 minus 0, it will be 3. This will be 0, 0, 0. This is 0 times 5, it will be 0. Minus 2.5 times minus is 0. It will still be minus 2.5. 5 times 1, it will be 5. 0 minus 1, it will be 0 minus 5, it will be minus 5. 50 times 5, that will be 250. This is minus 500. Minus 500 minus 250 to be minus 750. No, 5 times 50 to be 250. Minus 500 minus 250 to be minus 70. So this is the new row Z. 3 0 0 0 0. We have 3 0 0 0 0. Okay. Then we have minus 2.5, minus 5, minus 750. Minus 2.5, minus 5, and minus 750. Remember, I have told you that for the optimal solution to be achieved, all values in our objective function must either be 0 or negative. And this 3 is not 0, and it's neither is it negative. Neither it is negative. So you have to calculate a new pivot. New pivots have to be determined. So to calculate a pivot, I've told you that at the highest value, the column with the highest value of the objective function will be used. So the highest value in the objective function is 3. So we are going to use this column. We divide this by the value in this column. 200 divided by 1.5. 100 divided by 0.5, 50 divided by 0.5, 50 divided by 100, divided by 0. So we have 200 divided by 1.5. Then we have 100 divided by 0.5. Then we also have 50 divided by 0.5 and another 50 divided by 0. This will be 0, this will be 100, this will be 200, 200 divided by 1.5, that gives us 133. The least is 100. So I've told you that anytime you have a 0, that one should be ignored. So that means if the least is 100, this 0.5 should be our pivot. So if 0.5 here is our pivot, this is our pivot, our new pivot. So we are going to replace the letter C here by the letter A. So that means our new A row now, instead of C now, it will now becoming A. C is changing to A now. Our new A row. No, our old A row is 0.5, 0, 1, 0, 0, 0.25, 0, and 50. We have 0.5, 0, 1, 0, 0, 0.25, 0, and 50. You divide everything by 0.5, which is the value of the pivot. So 0.5 divided by 0.5. Therefore, new A row will be 1. This will be 0. 1 divided by 0.5, that will be 2. This will be 0, is 0. 0.25 divided by 0.5, that gives us 0.5. So this will be 0 and this will be 100. That is the value of the new A row. So the fifth table, fifth simplex tableau. So we have solution variable A, B, C, S1, S2, S3, S4, and solution quantity. So we have S1, S2. I've told you that A will be replacing C. Then we have B. S1, S2, A, and B. So S1, S2, A, B, and Z row, which is our objective function row. Our S1, this is the old S1 row, old row S1. We have 1.5000, 1.5, 0000, minus 0.25, minus 3, and 200. 1.5, 0, 0, 0, 0, minus 0.25, minus 3, and 200. Then what is our pivot row? Our row A, which is the new pivot row, and it's 1, 0, 2, 0, 0, 0.5, 0, 100. Our row A now, we have 1, 0, 2, 0, 0, 0.5, 0, and 100. Our target is to turn this row, this column to 0. For this to be 0, if you have 1.5 minus 1, it will be 0.5 and not equal to 0. So our new row S1 now. So for this to be 0, this has to be 1.5. Therefore, you multiply this row by 1.5. So 1.5 times 1 will be 1.5. 1.5 minus 1.5, that will be 0. 1.5 times 0, it will be 0. 0 minus 0 is 0. 1.5 times 2, and that will be 3. 3. 0 minus 3 will be minus 3. This will be 0. This will be 0. 1.5 times 0.5. That gives us 0.75. Minus 2.5 minus 0.75. That will give us 1. A minus 1. This is 0. Minus 3 minus 0, it will be minus 3. 1.5 times 100. That will be 150. 200 minus 150. That will give us 50. So this is the new row S1. So our new row S1, we have 0, 0, minus 3, 0, 0, minus 1, minus 3, and 50. So new row S1, we have 0, is 0, minus 3, is 0, is 0, minus 1, minus 3, and 50. Our new row S2 now. Remember, this row A is our new pivot row. Let me substitute into that. We have our pivot row 1, 0, 2, 0, 0, 0.50, and 100. 1 is 0, 2 is 0, is 0, is 0.5, is 0, and 100. Then our row S2 now. Old row S2. The old row S2 is 0.5, 0, 0, 0, is 0.5, is 0, 0, is 0, 1, minus 0.25 is 0 and 100. 1 minus 0.25 is 0 and 100. And our pivot row, that is row A, which is our pivot row, and it is 102, 102, 00, 0.5 is 0 and 100. Our target is to turn this to a 0. For this, we want this column to be 0. For this column to be 0, you have to multiply the 1 you have here. Because if you say 0.5 minus 1, it will give us minus 0.5. And you want to have a 0. You have to multiply the 1 here by 0.5 times 0.5. New row S2. You have 0.5 times 1. That will give us 0.5. 0.5 minus 0.5, this will be 0. If you multiply 0 times 0.5, it is 0, it will be 0. 0 minus 0, it will be 0. 0.5 times 2, that gives us 1. 0 minus 1 will be minus 1. This one will be 0. This will be 1. 0.5 times 0.5, that gives us 0.25. Minus 0.25 minus 0.25, that gives us is minus 0.5. This will be 0. 0.5 times 100, that will be 50. 100 minus 50 will be 50. Therefore, new row S2 now will be 0, 0, minus 1, 0, 1, minus 0.5, 0, and 50. 0, 0, minus 1, 0, 1, minus 0.5 is 0 and 50. Then we have row B. Row B. This value is already 0. So we don't need to subtract. So we replace it. 0, 1, 0, 0, 0, 0, 1, and 50. Is 0, 1, 0, 0, 0, 0, 1, and 50. Then we are left with row Z. So let's have old Z row. Our old Z row is 3, 0, 0, 0, 0, minus 2.5, minus 5, and minus 750. We have 3, 0, 0, 0, 0, minus 2.5, minus 5, and minus 750. So our row A now, which is the pivot row. Our pivot row, which is 102, 102, 0, 0, 0.5 is 0 and 100. Our target is to turn this column to 0. For this to be 0, you have to multiply this by 3 times 3. 3 times 1, that will be 3. 3 minus 3 is 0. This will be 0. 3 times 2, 6. 0 minus 6, that will be minus 6. This will be 0. This will be 0. 3 times 0.5, that will be 1.5. Minus 2.5 plus 1, minus 1.5, that gives us minus 4. This will be minus 5. Then 3 times 100, that will be 300. Minus 750 minus 300, that will be minus 1050. Minus 1050. That is our new Z row. So we have 0, 0, minus 6, 0, 0, minus 4, minus 5, and minus 1050 is 0, 0, minus 6, 0, 0, minus 4, minus 5, and minus 1050. If you look at this now, if you look at this table, all the values there are either 0 or negative. So that means the optimal solution has been achieved. Since the optimal solution has been achieved in this table, so now let's try to identify the optimal mix. So for the products involved are product A, B, and C. That means you can produce 100 units of product A. Produce 100 units of product A. Then produce 50 units of B, 50 units of product B. If you look at the slack, you have 50. For S1, slack 1, S1, 50. The slack represents unutilized resources. So unutilized, which of the resources did we denote by S1? If you go back to the question, S1, that is unused machine hours. Machine hours. Then S2. S2 also we have, that is also 50. And the S2 represents the unused component. Unused component. 1050 represents the maximum contribution achievable. Maximum contribution is 1050. Why these 4 and 5 represent the shadow price? Shadow price. The shadow price of S3 is 4. That of X4 is 5. This is the end of the solution to this question. My next presentation shall cover the dual constraint and the minimization problems. Thanks for watching ZICA. Don't forget to share it with others. Also like the video. Thanks.